Hello? Oh, can you hear me now? Cool. Okay. So, hello everyone. My name is Dominik, and I will be talking to you a little bit about improving your app's security. Quick word about me. So, I'm a senior software engineer at UST, and unfortunately, we are not hiring at the moment, or anyone in the future. I have around 6 years of experience in Flutter commercially. Prior to this, I had a background as a full stack developer, mostly focused on databases and backend. I also wanted to say that I'm not working in cybersecurity, so please take this presentation with a grain of salt. And about this, if you are handling any sensitive information, I strongly recommend that you hire a specialist, or suggest that your company does if you are not able to make that decision by yourself, just to ensure that proper security measures are met in your project, because working with vulnerable data is not something that you can take lightly. And I want to encourage you to keep this quote in your mind: security is a process, not a product. During the presentation and any time later when you'll be working on anything security related in your application, just to know that you cannot always, you can never be safe by just following one guide to security and leaving it out in the open. You always need to improve in order to keep being secure. So what's in this presentation? For sure, what you won't get is a ready-made recipe for a secure app, or you won't get a false sense of security. What you can get from this presentation is an overview of common security risks. You can get the practical tips to improve your app security, key threats to watch out for, and hopefully a newfound interest in the cybersecurity field, which you can explore later. We'll be exploring a selection of most severe, high priority, and important issues listed in the OWASP Mobile Top 10. Full list is available here if somebody wants to take a look. We won't be diving into all of them, mostly because we would run out of time, and I want to say something in between the different issues that we will be talking about. So, if you don't know what OWASP is, it's a non-profit organization founded in 2001, focused on improving software security. They provide a range of free tools to support secure programming and penetration testing, or you can get documentation from the like educational materials on what to do and what to watch out for in your applications or in your software in general. And let's start with the first one. First item on the mobile top 10 of biggest threats is improper use of credentials. It's a serious security threat that is probably really easy to execute. And the problem is that applications often fail to properly manage and secure authentication credentials, leaving them vulnerable to exploitation. And this can, of course, lead to unauthorized access and compromise our users' accounts, which can be, of course, bad for us and bad for our users. So let's explore a scenario. Let's imagine that we have an application with a hard-coded OpenAI key that we use in order to prompt OpenAI AI models with something that they will give us an answer to. An attacker can unpack the APK and get access to the source code and just find the API key in the extracted source code. And with the stolen key, of course, the attacker can now generate OpenAI responses without us probably even knowing, leading to unexpected cost and potential service abuse, which can even get us banned or fined by some companies or some government agencies. So let's take a look at on. Oh, okay, cool. A second scenario that I came up with is a remember me function, and believe me, I've seen things like this, so it's not a fiction. So we have an application with. Oh wow, we are going fast, aren't we? Okay. We have an application that has a remember me function, which stores the user login and password in the local database in order to support this function. If an attacker gains access to the user devices, either physically or by injecting something malicious into the phone itself, they can extract the credential, of course. And with the stolen credential, the attacker can then log in there as the user, essentially wreaking havoc around our application as well as the user data that is compromised now. Okay, so how to defend with from something like this? Let's start by saying that you should assume that everything in your application is public. There is nothing really secret in any application. If something is stored on someone's device, it's public. You just need to live with that. So what you can do other than that is if you are using API keys and you store them inside your application, you can regularly rotate them. This will prove beneficial because even if your API key is compromised, then you can just rotate it and it won't be anymore. And instead of storing keys directly in our app, we can use secret managers like AWS Secret Manager, Azure Key Vault, or Google Secret Manager. This way we don't store anything on the app side, and we store it on the backend. And if you are using other security things, we might end up even doing security. So a quick word about secret managers. They provide a fast and automated key rotation, which is really great if you end up in a situation where your API key is compromised. You want a really fast, want to be able to rotate it very fast so the users won't be affected, but at the same time you want to protect your business, so you want to disable the old key. This is great for that. Secrets are loaded in the runtime, so instead of storing them inside the binary, we are storing them either in the memory, or we just get them through SSL TLS connection from the backend, which is also really hard to listen to. So these features, all of them together, create a robust security system that's helpful with managing sensitive credentials, and this is a great thing to do if you use API keys or use any secrets that you need to have inside the application, but you cannot ship off to the backend. Consider just moving them, just the keys, to something that is stored on the cloud, so you can be a little bit more secure there. And I've scanned the pubdev to see what kind of secret managers are supported for the Flutters. I found two different libraries, and one of them is AWS Secret Manager. The problem with that is it's auto-generated, so be careful there. And the second one is Google Cloud Secret Manager, but I have a problem with that, and you can see that it's unverified uploaded there. And this doesn't sound good, especially if we are talking about security. So let's take a look at that. So, and we see that after some investigation, I found out his GitHub is Marcus Twitchell, and I found out from his LinkedIn, it's probably at this stage it's called stalking now. I found out that he's really working on V Ventures, but we cannot be sure that this is really him in the GitHub. It looks like him. It even has all the repositories, all the commits, etc. But me personally, if I'm talking about something as delicate as secret manager, I won't trust anything that comes up as unverified uploader. Okay. I was curious to see if a non-expert like me can somehow get access to secrets stored in the app's code. My plan was simple. I was going to get APK, try to unpack it with tools like APK2, unzip, or something like this. Find some resemblance of that code or any other code that I can use in order to do my discovery, and finally just try to find something that's interesting. So I did create an app like this, where I have a separate class for environment variables, and I'm just loading this secret here. So if you open it up, it's right there. It's not really secret, right? But yeah, this will do. And then, of course, what I did was I built the app, but this isn't specified there. I built the app in the release mode, just to be sure that I'm following the right protocol, and this is a real-world example. And I tried to unpack it. This is the first step. So I found a tool like this. It's called APK tool, and it's a tool that allows us to get an .apk file and unpack it like a normal zip. And if we look into it, what happens if we do something like this? There is a command, by the way. We can see that it's printing a lot of some warnings, but we don't really care about this. We care about getting, checking out the directory, and we see that there is a new folder there called exactly the same as the APK that we are using. And if we take a closer look, there is a lib folder that contains all the platforms and contains SO files for the app and for the Flutter framework. And this is interesting because if you don't know, Android builds Android apps built with Flutter have a Dart code compiled into native ARM machine code, and this is compiled as a SO or shared object files. So these files contain both the Dart code that is running your application, as well as the necessary part of the framework that is attached to it. So this is great. We can use this. But the problem is, okay, how do we open it? So the compiled SO files can be viewed by any hex editor. I, for my case, used XHD just because I was working on Windows. That's why also I didn't test macOS, but like iOS applications. But yeah, you can use any hex editor or any other tool that can deal with hex code. And if we take a closer look at what's inside, when we open up the libso file, we can see a bunch of nonsense. But if we take a closer look and spend a little time digging around this, I was able to find yeah, you can see there is my secret, and I should not be able to see that, and I can see that, so that's not good. Of course, there are ways to manage that exact scenario, but I will talk about them a little bit later. I think, yeah, come on. Okay. There is an env package. I don't know if you heard about it, but env package gets something, has a function built in called obfuscation. You can obfuscate your secret variables, and they should be secure. I'm saying secure because they are not really secure. And I have a personal problem with not really this package, but all the marketing around it. You see, if you type in env package in the Google, there is a good chance that you will find articles saying that this is the secure way of storing credentials in your application or API keys. This is not really a secure way. Just because obfuscation isn't security, it's helpful in order to stop attackers from trying, but it's not impossible to crack, especially if you are using XOR encryption, basic XOR encryption. It's really easy to reverse. If you have the key and the data, you can just XOR it once again, and there you go. You have the value back. There is a specific storage pattern inside the env built in. So they create a key that is the same length as the string that you are trying to encode, like obfuscate. So it's really easy if you are trying to use entropy in order to find two really similar arrays inside your SO library. You can do that, and if you are successful with that, you will be able to decode the secret. Of course, it's not as easy as I'm talking about, because let me say that I spent 20 hours trying to really do that and really reverse the envied obfuscation right from the release APK, and I failed miserably. But there is nothing to say that someone with a little bit more skills couldn't be able to do that. I'm pretty sure that someone with a better skills could. And the other thing is, I didn't have a high enough motivation probably, but if we are talking about money, and in most cases, if someone is doing something harmful to your app, like not a white hat hacker, but a black hat hacker, he will be trying to get hands on your money, and this is a greater motivation than what I have. Moving on. So, insufficient supply chain security. We have this security is when we can. Oh, sorry, I need to drink over. Okay, is that good? Okay. So attackers can inject malicious code and compromise build pipelines or tamper with the distribution process, and this can result in malicious code injection and data breaches that can impact both the development team and the users. Let's explore a scenario like this. We are using a third-party package that is widely used across the industry, and at some point, somebody updates it with malicious code, either by a compromised maintaining account or something else like a build pipeline. But the result is, our code probably picks this up automatically, because we don't use a card. We use a card system in our PubSpec. So it's marked as a minor update. It's automatically put into our next build. And when we build and release to the new version, the malicious code ends up on the user devices. In best case scenario, probably compromising our application, taking it down from the stores. In the worst case scenario, probably doing something to the data or to the user's phones. And of course, we can defend from against that. First, I propose to do good code reviews, because you need to understand that this threat can be not only external but also internal. If you hire an intern, you have a very big team. Nobody is looking over anybody's shoulder. There was a situation like this. I don't know if you heard, but there is a big concern in the USA right now. A lot of North Korea people are trying to be hired by biggest USA companies just to have access to their files. So this can happen. It's not something that I just imagined. And second, we can implement a strict version control in dependencies, and this can provide us a better look into how we can stop automatic updates. We can just review the next version of the package if it comes up before we decide to pull it into our code base. Third, we can of course check the package before we include it into our code base. There was a famous case, probably most of you heard about it. There were concerns about the DO package, just because it wasn't maintained by someone from the Europe or USA anymore. It was shipped to a Chinese company, and then it was sold again to someone completely new. It's fairly stable now, and it's open source, so we can look inside the code and see what's going on. But this can happen. And try to have secure build pipeline, because, like I said, this type of attack can not only happen from the perspective of pubdev, trying to get an update of your dependency. It can be injected when you are building your application on any CI/CD provider. Dependency version control. If you are using a carrot, this will lead to automatic updates of dependencies, probably without even you acknowledging that, just because anything that is marked as a minor update isn't really is automatically put inside your code base when you do a pubdev. If you just pull your dependencies, it will get pulled. I'm sorry, I forgot from the command, but I'm not an imposter. Trust me, I'm a Flutter developer. Okay, so this poses a security risk as automatic updates bypass manual security reviews and can introduce unexpected stuff without your awareness. And it's important to be cautious when using the carrot system, just because you are now in charge of your dependencies. If any security update is shipped to any of your dependency, you will need to update it manually. And this is exactly why Flutter team is a little bit skeptical about pinning them, and it's advising that if you really need to, you can just keep them up to date, but be careful because, if something like a bug fix or security patch comes in, you will need to do it manually. So you need to monitor the version of the packages that you are using. And there is also stuff like this, where why dependency pinning can be important is the Peace Not War incident. It involved a developer adding a protestware to a widely used open source package on the NPM, and the hidden code selectively targeted specific regions, mostly Russian regions, which just crashed the machines and started to write the disk contents with zeros instead of actual data. And while intent might have been a political statement, what it really did is it undermined the confidence in the open source ecosystem. So stuff like this, like dependency pinning, became a much bigger topic after that incident. And of course, it all depends on the level of paranoia that you apply to your security approach, to your security. And it depends, the level of paranoia that you should apply really depends on your project. Because if you are working with something that is critical, like, I don't know, like some medical tech that is keeping someone's heart beating, you probably need a high paranoia. But if you are working on something that is as easy as a note taken up, you don't probably need to really worry that much about the security. So, the more critical the application, the higher the paranoia should be, and you need to choose the right level for your application, or advise your colleagues, your team to do so accordingly. Then we have M3, insecure authentication or authorization, and it's relatively easy to exploit. Attackers can bypass login security, steal users' credentials, and escalate the privileges to gain unauthorized access. For example, move on. Yeah, come on. Okay, cool. Let's take a look at a few examples. For example, user role misuse, where the backend trusts the user role data sent from the app without actually checking it. And I've seen this pretty frequently across the projects that I work on. And you can just override it, and now the backend will think that you are admin. That's great. You can be missing authorization checks. For example, let's say your application relies on getting authorized, but few of your older endpoints is not really a part of that system. So you still keep calling them, but you don't need to provide any token or anything like this. this is a probable vector attack. The probable vector attack for anybody that will mean harm for your project. And our third one is an example where you are using something to protect user's account, which is not really that secure. For example, a 4-number PIN. It's easy to brute force. There is only 999 examples, possible combinations. So that's nothing. And yeah, how to mitigate? Give me a second. Thank you, Alicia, for bringing up the water, because I would have died without it. Zero trust approach is crucial. You should never trust the user or the mobile application. If there is a case like this where your application that you are working on is trusted by the backend, just tell the backend developer to not trust you. And you can even play with him on the dev environment, of course, not on production, but you can just play with him to show him that there is a problem if he trusts you too much. And you can enforce server-side authorization to validate user roles and permissions, not just the app. This is the right way to do it. You can require strong authentication, like secure passwords, MFA, like multi-factor authentication through the application, through physical keys or anything like this. And you can use biometric instead of weak pins. And this is probably, if you are working on local sign-in to your application, it's better to use biometrics than a simple pin. And of course, you can always implement rate limiting and brute force protection, so it gives you a little bit. It will take more time to brute force your application rather than just trying it really fast. M4, insufficient input-output validation. And this is really not that easy to exploit, but it's something interesting. And I wanted to talk about this specifically because it's not that common to occur in the mobile industry. The problem with that is that it can open you up to any type of SQL injection, command injection, or cross-site scripting. And let's explore a scenario like this. We have a mobile application that has a search feature that allows users to enter text to query the database. We have no validation whatsoever for the text that is being inputted there. So, for example, someone just inputs an SQL query, and this can lead, of course, to something that we wouldn't want to, like getting the information out of our database. And I'm talking about database, so my thought first when I heard about this was, okay, this doesn't really affect me as a mobile developer, right? But I'm always forgetting that this is something that we can have on the mobile side as well. For example, even your local database. Let's say that you have an application that is used on like a company's phone. And you sign in, you do stuff around the application yourself, then you sign out as your shift ends and someone else signs in. This stuff is being stored on the local database, so now the second person that goes in, if you are not clearing the database correctly, can access the information as well. Okay, so what can we do about this? We can validate the inputs. Of course, we can do a parameterized queries, and if you don't know anything about transactions and you are writing SQL queries, you are doing it wrong. And of course, anything that also reaches user's phone should be validated, should be safe, in order to secure the end user's side of spectrum of mobile applications. Then we have insecure communication. This is not that easy to exploit. Sorry. Attackers can intercept or manipulate encrypted data that is being transitioned around the through the network. And this is a problem because, let's take a look at the example like this. A user connects to a public Wi-Fi network, unaware that the attacker is trafficking, intercepting traffic, and this is something that we find common. I'm missing SSL pinning, so our mobile application doesn't really check if the server that is returning the calls is valid. And what the attacker does is changes the DNS for the domain that we are using, and just provides the mobile application with a fake response that this is the correct server. So if anything will be sent through to the server, it will be encrypted by the SSL. But the problem is it will end up on the wrong server. So that's not great. So what we can do in order to defend against insecure communication, we can avoid storing login credentials, of course. We can use short-lived auth tokens, and this is something that we should use. Basic auth is good, but for specific use cases. We can enforce certificate pinning, and this is something that I want to explore a little bit more. Because SSL pinning is a security technique where the app expects a specific SSL certificate from the server and rejects any mismatched certificate. So it will say, okay, I don't want to really communicate with you. You are not the person that you are trying to tell me you are. The problem with that is many CAs like Let's Encrypt issues short-lived certificates, like 90 days. So you would need to update the pin certificate inside your mobile application like every 90 days at most. Otherwise your users won't be able to connect to your API anymore. That's where you can use secret managers, by the way. Secret managers for the win. Yeah. And it's important not to pin root CA certificates, as that would trust all the all the certificates issued by that CA. Instead, pin only the specific certificates that you want to, in order to, improve the security. While attackers can technically modify the binaries to bypass the SSL pinning, it's rarely exploited just because it would be a much trouble to use. It might be used in order to explore your application more after it will be broken into, but that's it. It won't be installed on someone's phone in order to get the credentials. It's not really feasible anymore. Okay, SSL pinning in Flutter. Step 1, if you want to introduce something like this, get the certificate. You can either get that from your infrastructure backend team, or you can just get this from your browser. There is an easy way to export the certificate from your browser. Then what you want to do is, it's a little bit cut out, but what I did here is created my own HTTP client class, and I'm returning a future client, which will be a HTTP client with a specific loaded certificate. So I'm getting the certificate from the assets. I'm setting up the security context. It's important to see that there is an empty constructor there. There is an option to trust all the base certificates included in the platform, like all the root CAs for most common known providers. If you are really introducing SSL pinning, do you really want that? I'm not sure. So there is an option to disable that by just using the empty constructor. And then you just add the trusted certificates bytes to the context and create an HTTP client. In this case, it's IO client with HTTP client inside, with the security content inside as well. And then we just return it. You can do the same for the DO. So for the DO, you would just override the HTTP client adapter key. And you are basically doing the same. So IO had an HTTP client adapter, create HTTP client, get the security context, get the bytes, and return that and return the DO client. What I've shown here is something that won't be working on the Flutter web. So feel free, if you want to explore that, try it yourself and try it if you want. If you will be able to use it on Flutter web as well. Okay, moving on. Come on. Come on. Oh, yeah. Okay. So, we have insufficient privacy controls. M6. The app fails to secure sensitive user data, risking unauthorized access, like always, data leaks and privacy violations due to issues like insecure storage or extensive data collection or pure permission handling. Let's explore a scenario. So we are caching for performance to speed up the loading of the admin panel. We are caching the employee data locally. We are using unencrypted local database, making it easily accessible. And if an attacker could obtain sensitive employee details through a physical access to the device or just some malicious code inside the device, like installing a malware on the user's phone. Of course, this poses a security risk, so we should really do something about it. What we can do is store only what's necessary. So don't try to store everything about the user, cache anything that you need to. And if you do need to store some sensitive information, use strong encryption. And if even you are doing these two things, think about deleting the process data so they no longer linger around the application. Let's move to M7. Insufficient protection of binary files. Threat assessment is medium because it's not that really easy to exploit, but it can be used to do something called exploratory attacks. So going around your application and just checking what you are doing there in order to find a feasible attack vector. And this this is a bunch of stuff, so let's explore some examples. It can be used to extract API keys, which we talked about. It can be used to access hidden developers features. If you have a dev menu in your application, this is, I'm talking to you, this is not safe. Especially if you are doing something critical inside there. And, other than that, AI is a hot topic now, so maybe somebody can steal your embedded AI model. This is great. And what can you do about the binary file tampering? We can't really be always secure about them, or we can make the attacker's heart more painful. So we can use obfuscation, and obfuscation at multiple levels. For example, let's do obfuscation at a Dart level, then OS level, then do something inside packages like NV does, and now we have something that is pretty secure. It will take long time to crack if somebody wants to try that. And we can do integrated checks, so we can generate a checksum out of your entire code base and compare it when we are trying to reach out to the API. So if the application was tampered with, we can just reject the connection from this application. So it cannot be used to explore our API. And of course, we can avoid hard-coded secrets because it's bad to have hard-coded secrets. And if you want to use obfuscation, the problem is that on iOS there is no built-in support for obfuscation, making it a little bit difficult to use it on iOS. Android, on the other hand, provides an R8 tool, previously known as ProGuard, which can be used for code shrinking and obfuscation. And there is a built-in option in Flutter. If you are building an application, you can just provide an obfuscate flag, and it will add another level of obfuscation on top of it. Yeah, we saw that. Okay, cool. And you need to remember that decompiling Dart is painful, but it's not impossible. There is no widely available decompiler for modern Dart versions, mostly because each time Dart version increases, the underlying schema changes, and they need to really check the schema again and try to correct the compilers in order to get the Dart code back. But there are some tools that can be used to explore your application. like this. For example, the thing that I explore the most is Reflutter. Oh, not this one, sorry. Reflutter. This is a custom tool made for patching your binary. You can just take an APK, patch it, sign it again using something like Uber APK signer, and ship it to your mobile device, preferably rooted one, in order to explore what's going on. And if you open up application like this, dump it with like this, what it will be able to do is somebody is able to listen to all the calls, network calls, and also what it creates is a dump of all your method calls. Like all the methods that you have in your code base will be available in a dump. So it can be a little bit hard to explore if you are using obfuscation, because this changes names, and it's a little bit harder to track what's going on if you cannot read secret, but AA8678 as a function name. So that's something that to consider. But like I said, the compilation is not impossible, so it's not really something to keep us take as granted as you are secure because you are using that. It's not. Let's move to M9, insecure data storage, and I promise we are almost done. Like almost. I don't know how much. Yeah, almost done. Cool. We have weak or missing encryption on the database, and of course, if it can be used to exploit that, and I want to give you a real world example. I had an application to a popular app in Poland to book doctor appointments, and a function inside this application is you can write notes about any prescribed medicine or any previous illnesses inside the application, so it will be sent to the doctor. The problem was it's being stored as a PDF file first, and it's being stored inside on your device. So when I was trying to work on this presentation, I was going around different applications and their files, seeing what I can find. And I found this PDF file from like 8 months ago on my phone, unprotected, available to access without a root access or anything like this. And it had all the information about me, like my PESEL number, it had my illness history and any medication that I take. So I of course messaged the company saying, okay, this is a security risk. Can you do something about this? And they said after a few months, they came back to me and said, you know what? This isn't really a problem. The OS should handle that. It should encrypt the data. And if it didn't in your case, well, just reach out to your manufacturer. I'm using Pixel, by the way. Okay. But we will still fix it in the next release. So why you are fixing it if it's not a problem? Okay. But that's it. So what can we do to really protect ourselves against insecure data storage? We can use databases with strong encryptions. Ta-da! And of course, we can always limit data retention, so remove any data that you don't need. And for the databases with encryption, there is an ISA. ISA encryption works only for SQLite. So if you are using ISA and you are not using SQLite, but the no SQL option, there is no encryption for you, unfortunately. Hive was abandoned, but I still wanted to mention it because few people still probably use it. And it has a built-in support for encrypting the boxes. And Flutter Secure Storage, this is probably the best one if you want to keep your API keys from the secret managers, just because it relies on OS level, OS provided encryption and OS provided secure storage. Instead of relying on anything arbitrary made by Flutter Secure Storage, it relies on something that was provided with the OS. And Realm has a built-in encryption support as well. Okay. And about the data encryption in the mobile OS, this is something that is being used by the Flutter Secure Storage because you are using either Keychain or Secret Manager on Android. And other than that, all the files are really should be encrypted on your file, starting from Android 10. And iOS file encryption also works like this. So if you are trying to access, there's a few different access levels, and I haven't seen any Flutter library for accessing files that could support that. But just for your information, you can say, like, this file should be only encrypted when I demand it. And it's possible in the iOS system, but it's not possible in the libraries as for now. At least I don't know about this. And of course, there is stuff like root and jailbreak. And what it is something that gives us a full access to the device, bypassing the built-in security restrictions. And this can be used in, for example, in order to access folders that you are not supposed to, and explore what's inside them. So what we can do about it is we can try to detect if device is rooted and close the application. Unfortunately, this also can be binary patched, like really simple, or can be even patched through stuff like Magisk. And there are some native level implementation as well, but it's still not really secure. Like, this can be tampered with, and this can be made obsolete in few minutes probably for someone skilled. But yeah, if you are using if you are handling any sensitive data, you should probably still check for the jailbreak device. Just make the life a little bit harder, yeah. And okay, how to live with all of this? Let's start with don't panic. You don't need to immediately implement everything that we talked about, or anything that you can see on the Google when you search for security in mobile application. You'll mostly end up seeing the Envy article. Please don't follow it. If you are working on sensitive application, you either already have or should have a cyber security consultant. And if you don't have one and you are working with security vulnerable data, please advise your team to do so. And focus on identifying and mitigating the biggest risk in your code base. If, for example, something resonated with you on this presentation, maybe focus on that first. And implement security gradually, adding layers. This will make it more secure over time. And like I said, always, security is a journey, not a one-time fix. So just let the journey begin. Thank you. Thank you very much. That's it. Are there any questions? Okay. Do you mean like the iOS version? Okay, so the question was if attacker can unpack the Android version like I shown, can it also unpack an iOS version? Yes, it can. Reflutter, for example, allows for patching the EPA binary. And of course, you can always explore the iOS code inside the EPA as well. So that's possible. Yeah. Anything else? Come on. I don't bite. Okay.
You gave us few examples of packages which we can use. I wonder if there is any organization or any ranking of which one is the best and what's the criteria there, which one is secure and which one is not.
We are talking about the secret managers. Okay, so if you are talking about secret managers, there is no good answer. If you are using AWS services inside your application, you can use AWS Secret Manager, if you are alright with that. And to be honest, for all I know, if you are able to provide a stable and secure enough environment on your backend, you can just create your own version of the Secret Manager. As long as you are keeping an SSL TLS connection between the application and the backend server, you should be good to go. Come on. Come on. User ID as burnable information. Well, depends on the ID. Well, if you are using an ID that is a string with concatenated data, then it's something that you cannot burn, really. But at the same time, if you consider that you are passing IDs around in when you are calling endpoints, and it's not really mostly through the query parameters or anything else, but inside the path parameters, I would say that ID is a burnable data, yeah? Because on itself, like, this gives me nothing to work with. If I have access to your database, that's great. I can now explore more, but I need to get access to the database first. The ID gives me nothing on itself. Come on. Do you mean like database? Oh yeah. Okay. Okay. The question was for anybody that couldn't hear that was if I can recommend any package that available on the pubdev that handles encryption. And unfortunately, I don't have enough information about this. I haven't explored that topic. But probably anything that is open source, probably used by a lot of people, and ideally working with anything more than encryption algorithms is probably good to go. Go on.
This one is according to your advice to not use the caret in the pub spec, and I totally agree with that. And what about transitive dependencies that are bringing the carets that you don't see in your pub spec?
So, if your dependency is using carets, this is something that... Sorry? Mm-hmm. Okay. Mm-hmm. Okay, yeah. Okay, so the problem is it's really strongly unadvised to use caret system inside your libraries, but there is a problem. This is only they only advise to not use it, and people still end up using them. The same thing happens with the way you should update version of the application of a package. You should do a minor update if something is not a breaking change. If you are introducing something new, you should do a major update if something is a breaking change. And a lot of the maintainers don't really care about this and introduce something like this. I would like to say that you can do something like this about this, and you can use dependency override inside your pub spec. But other than that, there is no really an option to know that you are always safe. Yeah, this is something that can be a possible vector attack. Okay, I don't see any more. Okay, cool. When I checked recently, we had like 80% dependencies pinned to specific versions, and only 10% were still using the caret system. We will probably move out of using the caret system at all. Okay, thank you.